Good afternoon, everyone. Thank you for attending this session. My name is Mutyara Deviyana from Department of Industrial Engineering Universitas Indonesia. Today, I'm pleased to present our research entitled System Dynamics Modeling and Feedback Analysis of Last Mile Humanitarian Distribution Resilience in Indonesia. Indonesia is one of the most disaster-prone countries in the world, creating significant challenges in ensuring that humanitarian aid can reach affected communities effectively and on time. These challenges are particularly critical in the last mile distribution stage, where infrastructure damage, limited accessibility, and coordination issues often disrupt relief operations. Therefore, these studies aim to analyze the resilience of last mile humanitarian distributions infrastructure using a qualitative system dynamics approach through the development of a causal loop diagram. This is the outline of my presentation. Now, let me begin with the research background. You can see from the data, Indonesia is highly vulnerable to natural disaster due to its geographical location on the Pacific Ring of Fire. In humanitarian logistics, last mile distribution is considered the most critical and vulnerable stage because it's determined whether aid can reach affected communities. However, Indonesia's fragmented geography, infrastructure damage, limited accessibility, and coordination challenge often disrupt distributions activities. This issue may lead to delays and unequal aid delivery. Therefore, improving the resilience of last mile humanitarian distribution system has become an important research area. Previous studies have provided valuable insight into humanitarian logistics, particularly regarding coordinational operational performance and disaster response process. However, limited attention has been given to understanding the resilience of last mile distribution infrastructure from a feedback driven perspective, especially the dynamics interactions among transportation capacity, accessibility, information quality, and coordination mechanism remain unexplored. Therefore, this study addressed this gap by applying a qualitative system dynamics approach through the development of a causal loop diagram. And for the methodology, the study adopts a qualitative system dynamics approach. First, a literature review and a contextual analysis were conducted to identify key factors affecting last mile humanitarian distribution's resilience in Indonesia. And second, a causal loop diagram was developed to represent the causal relationship that feedback structures among system variables. Finally, the CLD was analyzed qualitatively to identify reinforcing and balancing feedback loop that influence distribution performance and resilience. This is my CLD overview. The CLD illustrates the dynamics interactions affecting humanitarian distribution's resilience rather than being determined by a single factor. Resilience emergency from the interactions between infrastructure capacity, accessibility, information feasibility, coordination effectiveness, and operational pressure. In system dynamics, system behavior is driven by feedback loops. These feedback loops can be categorized into balancing loop and reinforcing loop. Balancing loops act as a stabilizing mechanism that help the system move toward equilibrium, while reinforcing loops of life change and can either strengthen resilience or increase system vulnerability over time. The first balancing loop demonstrates how increasing local distribution capacity improves transportation capability and accelerates aid delivery. As more humanitarian needs are fulfilled, operational pressure decreases, allowing the system to gradually stabilize. However, the loop also highlights that excessive aid allocation without considering local distribution capacity may create cognition and reduce accessibility. Therefore, resilience depends on aligning aid allocation with existing infrastructure capacity. The second balancing loop emphasizes the role of information quality and coordination effectiveness. Better information visibility improves that accuracy more needs assessment, leading to more appropriate aid allocation. As aid distribution becomes more accurate, trust and coordinations among stakeholders improve, supporting better decisions making that help the system maintain stable performance under uncertain conditions. Unlike balancing loops, reinforcing loops continuously amplify system behavior. Depending on the feedback structure, they can either improve resilience or increase operational vulnerability. These loops illustrates how unmet humanitarian needs can increase public panic and political pressure. Under pressure, decision makers may allocate more aid rapidly. However, when it exceeds transportation and distribution capacity, cognition occurs, accessibility decrease, and deliver performance deteriorates as a result. Unmet aid needs continue to increase, creating even more pressure. This creates a friction cycle that amplifies system vulnerability. Unlike a reinforcing one, this reinforcing loops generates positive effect, improve information visibility, enhance data quality and decision-making accuracy. Better decisions improve coordinations and public trust, which further strengthens information sharing across stakeholders. This creates a virtuous cycle that continuously enhances resilience and system performance. This loop highlights how excessively aid accumulation at centralized distribution centers can overload infrastructure capacity. Overall, the analysis shows that resilience is not determined by a single factor. Instead, it emerges from the interactions between balancing loop and reinforcing loop feedback loops. Balancing loops help stabilize distribution performance through capacity alignment and effective coordination, while reinforcing loop can either strengthen resilience through information sharing or increase vulnerable through operational pressure and cognition. Therefore, improving humanitarian distribution's resilience requires an integrated approach that combines infrastructure capability, information visibility, and stakeholders coordinations. The findings indicate that resilience is not only determined by transportation infrastructure, information visibility, coordination effectiveness, and accessibility play equals important roles. Therefore, improving humanitarian distribution's resilience requires an integrated approach that combines infrastructure development, information system, and stakeholders coordinations. In conclusions, this study demonstrates that resilience of last mile humanitarian distribution is shaped by dynamic feedback interactions among information infrastructure, coordination mechanism, and operational pressures. The analysis identified both balancing and reinforcing loops that influence system performance. The finding highlight that resilience depends not only on a physical infrastructure but only on information visibility and stakeholder coordinations. Future research can be extend this work by developing quantitative simulations, models, and evaluating policy interventions under various disaster scenarios. Understanding feedback structure is essential for designing more resilient and adaptive humanitarian distributions system in disaster-prone regions such as Indonesia. Okay, thank you for listening.